Hey there, got a big networking exam coming up? Feeling that little bit of stress? Well, you're in the right place. We are going to turn that stress into some serious confidence. Okay, let's get right into this ultimate study guide.
Are you kind of getting lost in all the terms? LANs, WANs, clients, servers? Yeah, it can be a lot. But don't you worry, in the next couple of minutes, we are going to make it all crystal clear so you can walk into that test feeling like you own it.
So here's our roadmap. We're going to start with the basics, what a network even is. Then we'll get into the why, cover the different types, super important, look at how they're built, and then wrap it all up by connecting it to the stuff you use every single day. Let's do this.
Okay, first things first. Before we can get into all the cool, complex stuff, we got to have a solid foundation. So, what exactly is a computer network? At its heart, it's actually really simple. A network is just a bunch of computers that are connected so they can talk to each other. And why do they do that? Well, the magic phrase for your exam is to share resources and services. Think about it. In an office, instead of every single person having their own printer, they can all connect to one big fancy one. That's a network making life easier.
And this image right here, this is that idea in action. You see all those workstations? Those are just regular computers, and they're all connected to that one central file server. This means everybody can get to the same project files from one spot. No more emailing files back and forth and wondering who has the latest version. It's just efficient.
Okay, so we know what a network is, but I guarantee your exam is going to ask why they are so important. So let's lock in the 4 key benefits you absolutely have to know.
These 4 points are gold. Exchanging information. That's the obvious one. Sending emails, files, whatever. Sharing hardware. That's the printer example, and it's a huge money saver. Preserving information just means your data is all backed up in one safe place. And protecting information, well, that's all about security and making sure only the right people can see the right stuff.
All right, listen up because this is a big one. This is pretty much guaranteed to be on your exam. Networks aren't all the same size, and you need to know the 3 main types: LAN, MAN, and WAN.
So first up is the LAN, the local area network. And the name kind of says it all, right? It's local. Think of the Wi-Fi in your house, or at school, or in a coffee shop. Because all the devices are so close together, the data doesn't have far to go, and that's why LANs are super fast.
Okay, now let's zoom out a little to the MAN, the Metropolitan Area Network. So this is bigger than your house network. It can cover a whole city. A perfect example, think about a citywide cable TV network, or a network that connects all the branches of a public library across town.
And the biggest one of all, the WAN, the Wide Area Network. This is the big kahuna, spanning countries or even the entire globe. You know the best example of a WAN? The internet. It's the ultimate WAN. Now, there's a trade-off. Because the data has to travel such huge distances, the speeds are generally slower than what you get on your little local LAN.
And check this out. This table lays it all out perfectly. Seriously, if you're going to screenshot one slide, this is it. It's got everything you need to remember. LAN, small and fast. WAN, huge and a bit slower. MAN, right there in the middle. Just memorize this chart and you are set.
So, how do these all work together? Well, you can think of a WAN as the glue that connects a bunch of different LANs. So a company's office in New York, that's a LAN, can talk to its office in London, another LAN, by using the internet, which is the WAN connecting them. This diagram shows that relationship perfectly.
So we know the types. Now let's peek under the hood and see how networks are actually structured. This is all about the architecture, kind of like the blueprint for the whole system.
So you've really got 2 main ways to do this. On the left, you've got a centralized network. Think of this like an old-school kingdom. One super powerful computer, the mainframe, is the king and does all the thinking. The other terminals are they just take orders. But on the right, you have a distributed network, which is what we pretty much all use today. This is more of a democracy, where all the computers share the work.
Now, inside that democratic distributed world, there are 2 main setups. First is client-server. Here, you have one computer that's the dedicated server. It's the boss. It provides services, like hosting a website, to all the other computers, which are the clients. But then, you have peer-to-peer. In this world, there is no boss. Every computer is an equal, a peer, and they can share things directly with each other.
And of course, with all this information flying around everywhere, you have to keep it safe. That's where network security comes in. It's really just about protecting data from anyone who isn't supposed to see it.
This can be anything from someone trying to hack your password to something as simple as somebody physically unplugging a server. Both are huge security problems.
Okay, let's bring all this theory back to real life. Why does any of this stuff matter? Well, because it powers pretty much everything you do online.
I mean, just look at this list. Every single one of these things runs on a network. Sending an email, browsing the web, chatting with your friends, ordering food through an app, it is all possible because of the networking ideas we just covered. It's kind of crazy when you think about it.
And the World Wide Web, it might just be the most famous network application of them all. It's this amazing system that lets completely different types of computers, a Mac, a PC, your phone, whatever, all running totally different software, talk to each other and share web pages. That right there is the magic of networking.
So, feeling better? Feeling ready? Let's do one last little check-in. What's the main difference between a client-server and a peer-to-peer network? Just think about it. It all boils down to one simple question. Is there a central boss, a server, or is everybody equal? You've totally got this. Now go ace that exam.
Have you ever really stopped to think about it? You send an email, you stream a video. How does that information actually get from your screen to somewhere else, whether it's across the room or across the planet? Well, it's not magic. It's computer networks. And that's what we're going to dig into today, the absolute fundamentals of how our digital world is all connected.
Now, seriously, think about this for a second. Before we had networks, you'd have to copy a file onto a floppy disk, hop in your car, drive over to your friend's house, and physically hand it to them. It was slow, it was a pain, and it was just clunky. That exact problem, the simple need to share stuff easily, is the entire reason computer networks were even invented.
So here's our game plan. We're going to start with a basic why, the whole reason for connecting computers in the first place. Then we'll get into all the perks, look at the different blueprints for how networks are built, scale things up from local to global, and finally, see how this all led to the internet we can't live without. Okay, let's jump right in with that fundamental question. Why even bother linking computers together? Well, like the slide says, it's all about finding a really simple, elegant solution to a massive problem. At its very heart, this is all a network is. It's just a bunch of computers hooked together with something. Could be a cable, could be a Wi-Fi signal, so they can talk to each other. It's the perfect answer to our floppy disk problem. Instead of physically moving the disk, you're just moving the data digitally. So much easier. And this picture shows that idea perfectly. You've got your individual computers, your workstations, and they're all connected to one central file server. Just think of that server as a shared digital filing cabinet or a library. It lets everybody on the network get to the same files or even use the same printer without needing a copy for every single person. It didn't take long for people to realize this was about way more than just sharing a few documents. Connecting computers unlocked a whole bunch of advantages that, honestly, form the foundation of how we all work and communicate today. And the perks are huge. First, obviously, exchanging information becomes effortless. Second, you get to share expensive hardware. An office doesn't need a printer on every desk. Everyone can just connect to one. Plus, you can back up all your important data to a central safe place. And maybe most importantly, you can actually control who gets to see what, which is a huge deal for security. All right, so not all networks are created equal. Just like buildings have different architectural blueprints, networks have different structures depending on what they're for. Let's take a look at the two main ways they're designed. So this shows a really important shift in how we think about networks. On the left, you see a centralized network. In this old-school model, one giant mainframe computer does all the thinking, and all the other terminals are basically just dumb screens and keyboards. But on the right, you see a distributed network, where the processing power is spread out among all the computers. This makes the whole system a lot more flexible and powerful. Now, that leads us to two main setups you see today. On the left is client-server. Think of this like a company hierarchy. The server is the boss, dishing out services and data to all the clients. It's awesome for security and organization. Then on the right, you have peer-to-peer, which is way more democratic. Every computer is an equal peer, and they all talk directly to each other. It's much simpler and cheaper for small setups like sharing files at home. All right, we've talked about the how of network design. Now let's talk about the how big. Because the scale of a network can go from a single room all the way up to, well, the entire planet. Generally, we classify networks by how much ground they cover. The smallest is a LAN, a local area network. A step up from that is a MAN, or a metropolitan area network, which might cover a whole city.
And the biggest of them all is a WAN, the Wide Area Network, which can span countries and continents. You use a LAN every single day, probably without even thinking about it. Your home Wi-Fi? That's a LAN. The network at your office or school? That's a LAN too. Because they're confined to a small area, the connections are short, which means you get really, really fast data speeds.
A WAN, on the other hand, is the total opposite. Its entire job is to connect different locations that are super far apart. And the way it does that is by being a network of networks. It basically links a bunch of smaller LANs together using long-distance tech, like fiber optic cables or even satellites.
This diagram just nails that concept. The WAN is the big backbone, the data superhighway, if you will, that connects all the different offices or cities, and each one of those locations has its own little local area network. This structure right here is what makes global communication possible.
And all of this, every concept we've covered, it all leads to the biggest, most famous wide area network there is, the Internet. The Internet is basically the ultimate WAN, just scaled up to cover the entire globe. Now, this is the key thing to remember. The Internet isn't one single thing. It's a gigantic, worldwide collection of millions of public and private networks, from tiny homelands to massive government WANs, all agreeing to speak the same digital language. And that's what lets us share information instantly with anyone, anywhere. So once you have this incredible global connection, you can start building amazing things on top of it. And that's where all the stuff we use every day comes from. Email, browsing the web, chatting online, shopping, all of these are just applications built to run on this giant network of networks. Take email, for example. It was one of the internet's first killer apps. It's just a simple system for sending messages. And the address format itself tells the story of the network. You have your unique username at a specific server location somewhere out there on the network. It was absolutely revolutionary. And then there's the World Wide Web. Okay, big point here. The web and the internet are not the same thing. Think of it this way. The internet is the global network of roads and highways. The World Wide Web is all the houses, stores, and destinations you can visit using those roads. It's the system of interconnected pages we navigate with a browser. And the magic ingredient is the hyperlink, which connects everything together. So we've gone all the way from solving a problem with a single floppy disk to a global web connecting billions of machines. The tech is absolutely incredible. But it all leads to a much bigger question, doesn't it? We've seen how networks connect machines, but how do they truly connect people? Beyond all the cables and code, how has this network fundamentally changed how we live, how we relate to each other, and who we are? That's the real story.